All right, hey team, welcome to Colbyashi Maru, the show where devs all over the world boldly face off against the most logical tools of the web. I'm Colby Fayok, your Space Jelly commander and host of today's challenge. Today we have Jamund Furgeson. Jamund is a front-end engineer over at Amazon and also an egghead instructor. He's also into mental health tech and as well as punk and hardcore music. So let's bring him in and find out what his favorite bands are. Jamund, do you want to give yourself a quick intro or have anything you'd like to add?
Uh, no, I'm just super happy to be here. Excited to show off some basic HTML and CSS stuff. Favorite bands, really like Touche Amore, Julian Baker. I don't know, a bunch of other cool bands. I can't think of them on the spot.
Oh man, I'm so out of that world. But back in high school, I used to listen. I don't know if you like Under Oath and like the Used and those kind of things, or is that too poppy?
Hey, I grew up in Seattle and was really into our local hardcore scene here, bands like Trial and Champion and Stay Gold, and then kind of got into like the broader punk and hardcore music from local bands, and then bands that would tour like Bane and stuff like that. So yeah, now I'm kind of more older and mellowed out and listen to lots of indie music, but I still love punk and hardcore. It still has my heart.
That's awesome. Cool. Well, if you're new to Colbyashi Maru, our guests will have 1 hour to complete their challenge. Through that time, Jamin will try to talk out loud as he's working through the challenge. I'll also be sure to ask questions along the way, but if you have a question, make sure you ask it in chat and I'll definitely field it over to Jamin. So today, he's going to face off against building Pac-Man with the fundamentals of the web, vanilla, JavaScript, HTML, and CSS. If he doesn't finish, he's going, not all is not lost. We'll see if we have a little bit of time to finish up, or we'll chat about what the next steps might look like. So Jamin, before we actually get started, I'm going to put your screen on screen. Do you want to talk a little bit about the tools you'll be using or anything before we actually dive in?
Just go for it, and I'll just talk as I go.
Okay, sounds great. So I will pull up the timer and we should be off.
All right. Am I good to start?
You're good to go.
Okay, so I'm using CodeBin here. It's just a web-based editor that gives us HTML, CSS, and JavaScript in one place. I thought it would be really easy for showing off what we were building today. And here's a kind of a sneak peek. This is not like a fully working, awesome Pac-Man. This is a fun project for learning stuff. And you can see you've got this little emoji that kind of goes around, can eat the fruits, can come up. And if you do run into one of the ghosts, which is pretty hard since they don't actually move yet, your emoji changes and you die. So it's pretty fun and cute. And I'll show you how I built it and show you how to build it. And if we finish it, we can add even better features. So I'm going to start over here in this empty code pen. I'm going to make a div class equals game. And that's all the HTML we'll be using so far. So we can close that out. And then in the CSS, I'm going to copy a few things over here, but we're going to set some variables for the different things that we want. And for my cool color, I chose this kind of purple color, which I use for the outline and everything. We'll get to that in a second. For our candy, we've got these cherries. For the ghost, sort of your enemy, we use this emoji, what I'm calling the critter, or your little character, your Pac-Man character. We'll use a happy face, and then if you die, you get this sad face. So I think it's really nice to use CSS variables. I've never really used them in a real project, so it's fun just messing around on this to kind of get a chance to use them. And then I guess the first thing that we want to do is add like a border. Well, let's set the background. So background black, and then we're gonna for our game, we're gonna do, let's see, width, height of 300 pixels. And I guess we need our border. So we'll do border 1 pix solid, and then we're going to use our variable for our color. And yeah, it's okay. Let's do margin 0 auto here, center it. We'll do 2 pixels. And then I love a border radius. I grew up in web development when CSS3 was coming out. So like text shadow and border radius. That is like what I learned on. I mean, I really like dived into that, and I thought it was like the best thing in the world. So I still am guilty of like overusing some of the CSS3 stuff, even though all that's like way out of fashion now, but I love it forever. Okay, so that's our little game. And then the next thing we need to think about is like, how do we fill in all the other stuff in the game? And so, you know, when you have something like Pac-Man, you've got like you have all these places that you can go and you can not go in. And so the way that I like to model that out in my JavaScript is with like, let me show you here, is by defining a string, and everything's going to fit into a string. It's kind of fun. So we'll say, let's say our board, and we'll use backticks, and it's literally going to be a bunch of digits and characters. So 8 is going to be candy, and then 0 is just going to be like empty. Well, it's going to be those little dots, and then 1 will be like a wall. So we're going to do this kind of just weird stuff here to make out a the game board. And I've got one that I used earlier. We'll just grab that one from the bottom over here. But the idea is that we're going to convert this string. It's not like binary code. It's literally just a map of what goes on the game board, what the game looks like. So, and this little string is going to represent everything that you see. So we'll start with that. And then we need to parse this out. So what we're going to do is we're basically going to convert this string here into a bunch of HTML elements and shove them inside of our game. So next thing we need to do is we will say, let's see, we got to trim the white space around the edge. So we'll say const board lowercase equals board.trim. And then we're going to split the edges here. We're going to convert this to an array first thing. So then we're going to do a map line.split on empty string. So what we've done with this, and I don't know, maybe we can console.log it, is we converted this into an array of arrays. And then we'll convert that, or we'll use that array of arrays to populate all of the elements inside of our game board, which we're going to need in a minute. So we've got our board there. Now let's go ahead and grab the DOM element that we're going to need to work off. So const game equals document.query selector game. So tell me if I'm saying too much. Like, do you need to hear me say what I'm typing? Maybe.
No, I think you're doing great. You know, the chat let us know. You're doing a great job, so I haven't had any questions to ask yet.
Rad. Well, let me know if you do. So the next thing that we're going to do, like I said, we got to take this like string representation of our game and actually convert that into DOM elements. So we're going to create a document fragment, which is kind of an old school way before you have React and cool things. You shove a bunch of elements into a document fragment, and then you append that into your element. So we'll say game.append frag at the end. And then inside here, we're going to loop over our nested array. So we'll say, let's see, we called it board.
So the document fragment, actually, I haven't seen that before. Is it kind of similar to if you were to create a div and nest everything inside that div? Like, is that similar?
Yeah,
kind of idea?
I mean, you know, like in React, how you've got that little empty thing,
yeah.
wrap. It's kind of like that. It's like saying, here's a bunch of HTML elements, and in the old days, right? Well, of web development, you just like you loop through and like add 50 DOM elements. We're going to be adding here, I don't know, 200 elements into this thing. So instead of going one by one appending and then that reflows the whole page, you add them all to this fragment, and then you add the fragment in at once. So it's just one reflow for the whole thing.
Ah, interesting.
Yeah, it's not something you need because there's modern frameworks, but since we're doing this by scratch, from scratch, you still have to do it. So I just want to show also real quick here. I'm gonna what my board looks like, just to understand like what the array is that we're working with. So if I go into console, you see we've got this array of arrays, and then each of these is just this string. We're going to use that string and convert that to a specific class. So again, 8 is the cherry, 0 is the dot, and 1 is a wall. It's kind of weird, but I don't know. I thought it was clever and kind of like a compact way to define what our game board looks like. And it'll be fun later when we want to change the layout. It's just like, oh, just change the string. So we're looping through here. Now we're going to make a bunch of divs, document.create element div. Wow, I like React so much better, but here we are. Div.classlist.add, where we're going to give every single thing in this, every single item in this, we're going to give it the class of square, because you see that like I'm going to do this here just to show kind of how this works. If you go to an individual dot here, I'm going to add a border. So you can kind of see this is, it's not actually square, because, but the idea is this is just one rectangle and they're all equal shapes. And so when we decide where things are going to land, it's all going to be sort of based on this grid where they fit. It's going to be cool. So let's get back into it now. Let's see, we created a div, we added the square class, and then we're going to have like an additional class based on the content we want. So we're going to call that our modifier. So for this, I have this cool nested ternary I'm going to use. Forgive me. So if the item in our board is an 8, then we'll give it the candy class. Otherwise, if the item is 1, we'll give it the wall class. Otherwise, it's going to get the dot class. And we'll define those classes in a bit, but we already defined the variables that we're going to use to populate what those look like. And then div.classlist.add. Oh, I don't need to add this twice. I think you can do 2 things at once here. Square and modifier. I might be wrong. We'll see if it breaks. And frag.append div. So we're adding all of these things to the document fragment. Then we're appending them all to our game element at the bottom. So this should actually give us something in here. So let's go and inspect it, our element. I gotta put this back so y'all can see it. It's gonna take up a lot of space, but if I go here over to elements, you should see inside of our game, we now have dozens of these little elements, okay? There's so many of them, one for each of those characters. And so now we can do some fun things. Let's go back into our CSS. And I guess like pretty important thing that we need to do is figure out how we're gonna lay out all of those elements. And I think just for kicks here, I just want gonna do square border 1 pic solid pink. So when we can start seeing those squares, they'll show up. Right now, it's just a massive mess because they're all thrown in there. So we need to add a few more little details here, and we're going to use CSS grid. So I'm going to type display grid, and then we're going to use this cool thing, grid template columns. Now, you can ask me about this. I'm not perfect on the syntax. I'm not expert at it, but we're going to say we want, because I know already how many items there are, I'm going to say we're going to have 24 columns across, and it's going to use this cool thing called 1FR, which is 1 fraction of 24. So it takes the space that you have, and if you use this 1FR, it's just going to split it up into however many that you repeat across, which is pretty cool. And then for reasons which I haven't exactly figured out, we also want to define the rows. So by default, it sort of figures it out, but we also want to tell it explicitly how many rows we're going to have, because we're going to add in additional elements in here, like our characters that really aren't part of the grid, and we don't want them to be laid out. So we're going to say there's going to be 8 rows, and those are also going to be split up using that 1FR, 1 fraction of the grid. So I haven't used grid syntax a lot in my sort of day job, but it's fun to have a chance to try out the CSS grid because it's really cool. One thing to note about CSS grid is even though you have a 2-dimensional plane here, we're laying out, we've got 24 by 8, and it's pretty clear to see with the border on how that lays out. All of these are just direct children of the game element. So these are all children of the div. There's just one level deep. You know, normally if you think about laying something like this out, you might have a div for each row, but with grid, you make them all immediate children, and then they get kind of split up like that. A couple other things we're going to add here real quick. We're going to add overflow hidden. Because we have the rounded corners, we don't want things to go over the side. And then so that we can position some of the characters, we're going to do position relative, which is going to help us later. Okay, so now we've got all of our squares, but we need to make the squares look cooler. Obviously, just having the pink border isn't quite cutting it. We need this to look something like a Pac-Man game. So the first thing we're going to do is add the candy. So I'll say .square.candy : after. And then we're going to use content var -- candy, which is going to set this up. Oh, yeah, it's good. Candy. Cool. So I'm not using my IDE, so I'm missing some of the magic here. But yeah, so now we've got candy in the corners, and all we had to do was say, for the after pseudo element, this is what the content's going to be, and it references what's there defined in our root CSS variables. I just think
That's
this
a
is
great
magic.
use.
We are in, I don't know, we're in the future times of CSS, and it's lovely. So, then to style this, I came up with like, if I mess with the line height a little bit, I can kind of center this. This is like not like there's probably better ways, but I got this to work. It looks centered. I'm happy with those candies. And then let's do our dots. So square dot dot after, oops, colon after. So you know they've got to eat these dots, whatever food that our little emojis need to eat. For that, we're just going to use a period. And then we're going to set the font size to 2EM to make it a little bit bigger. So it's a healthy morsel of food there. And then again, we're going to mess with the line height and the padding to just kind of center that how we want it. Okay, so now we've got some food. And now we need to make the walls. Now, in another version of this game that I have, which is called Candy Critters, which is kind of my daughter basically had this idea. And we made this and it was cute. One of the hardest things to figure out was how do you do this sort of like outline of the wall? Because what we're gonna do for a wall is just have like these hard wall pieces. And let me get rid of the pink border now that we're about to have a wall. But these hard wall pieces, which is gonna be fine. But doing the cool, let me just grab this. So we're gonna say background var is our purple color. So now we've got, you know, the basic game board here. But if we wanted to do these cool outlines, I thought for a really long time how to do this. And what you'll have to do, we're definitely not gonna have time to do it in this particular session, but you add like, I first tried to use those selectors that were like, if I have a thing next to me on the right and on the left that's empty, then, you know, round the corner, because it's all about that. But it ends up that if you add like a whole bunch of like, you know, you can use JavaScript to sort of detect if it's continuing, and if it's continuing, you don't want to have the bottom border. Otherwise, you do. It's really fun, and you can look at the source code on Candy Critters if you want to learn how it works. But it was like way more code than I thought it was going to be, just to get like a nice background or a nice border around the walls.
And just a quick note, I don't know if you heard the beeping. That's you have 45 minutes left.
We are doing just fine. Look, we've got the background set up, and I'm pretty happy about it. So the next thing we're going to create now is what I call our critter. And that's going to be the creature, the thing that's walking around the page. We've got at the top, we've decided that our critter is going to be this happy face emoji. And this is going to be fun part, actually. But first, let's give the critter needs a couple of things to work. So we're going to set up the CSS now. It's going to be positioned absolutely, because we're going to actually make it a child. And then it's going to have an after again, because you can't use content directly on the element. You can use it on the pseudo element. So we'll say content colon var dash dash critter. So there shouldn't be any critter on the page yet. And I'm also going to do the ghost. I'll define the ghost. We'll see if we get to ghost. But the ghost is similar, dash dash ghost. And the ghost is also going to need to be position absolute. So that's all the CSS that we're going to need, I think, for the entire game. Let's move back into JavaScript land here. And the next thing we need to do is create our little critter, our little friend that's going to be walking around and doing things with us. And so the most basic way to do that is to just create our critter, const critter. We're going to clean this up a bit in a minute, is document.create element div critter.classlist.add critter, and then game.append critter. Is that going to work? Work. Hey, there he is. Okay, there's our critter, our happy face up at the top left, right. And what you start thinking is, okay, well, now that we have it, how do we put it where we want it? And this is where, when you're making a game, you have to start thinking like, probably just like shoving all this code in like the root isn't good. We need to start organizing our stuff a little bit. And this is where the not very popular classes come in. I know everyone like hates on classes, and I'm fine with that.
Yeah, I don't mind them.
We're doing web code, but honestly, like when you're making a game, it's really helpful to think about, oh, this is a thing that moves, and this is a thing that has a position. And so modeling that in an object-oriented way is great. It's just fantastic. So for our critter, we're gonna say this.x equals 12, this.y equals 8. We're gonna give it a position that is in XY coordinates that references our grid that we have. And then we can move the code to create our element into our critter class. We're gonna get rid of this, and then we'll say, we'll create a new critter, const critter equals new critter, and then depend critter.l. And then this is like the next thing we got to go. We're going to add a draw method here. Draw, and in our draw method, we're going to figure out based on, it's like surprisingly annoying to convert the XY coordinates basically. So I'm like, I know I need 12, 8. I want it to go down here at the bottom. But in order to do that, you basically have to like do some math. And we need to figure out the width of each individual square to be able to perform that math. And so in order to get that square width and square height, we're going to use something which I haven't really used much before called get computed style. Because if I go and just try to say something like, let's see, const document dot query selector, dot square, width equals style dot width. We don't actually define the width directly, and so this is going to be empty. But if you use get computed style, I'm going to say window dot get computed style and pass in our element. So I'll say const square equals document to query selector square. That'll just grab the first square it finds. And then you can say width equals document or window dot get compute, or sorry, I'll say const style equals window dot get computed style square. Now this will have, watch this, style, I'm gonna log this style dot width, style dot height. So it's gonna have the like computed style, not just, because it's Flexbox, we don't give it a style. So if we go down here, so 25 pix and 40 pix high. So it's kind of fun. I thought that was a clever thing that I learned while making this. And one thing that really got me was because we have kind of a random number here, if I actually go into inspect on the element and click computed, yeah, I guess we're good, 25, 40. Sometimes when I was trying this, I had an odd number, so it was a fractional number, and it would still give it me an integer, and it was like everything was off a little bit. But and I had another way to grab that, but we're gonna use this for now. So we've got our square width and square height. So we're gonna make those constants. Const square width equals, and I'm gonna do this, const square height. This is all about being able to position our characters on the game board. Parse int style.
And because you're using CSS grid, you can safely know that all the squares are going to be the same size, right?
Everything's exactly the same size. I didn't have to define any of that. And obviously I could just set the width and height. Like there's like a million ways to do this. This is just one fun way that taught me a few things. But now with the square width and square height, and then my little surprisingly annoying algorithm here, I'm able to get my character somewhere on the screen where I want the character. And so if I change this to, let's say 10, in about 2 seconds, it'll move over. If I change this to 3, it'll move around. So, and you can see it's like, it's not like perfectly on the dot. Like it's like close enough though. This is
still
good.
Eating it.
Yeah, it's still eating it. It's happy. So now we have, you can kind of understand where we're headed here. We've got this draw method that will draw it. We can set like an XY coordinate and then redraw it. So the idea where we're going from here is, let's give it a position, a new position, in a little, let's redraw it. Then in another 300 milliseconds or whatever, we'll give it a new position and redraw it. That's how we're going to start animating this thing. But before we do that, I'd like to quickly refactor one thing. So like I mentioned earlier, we've got all this kind of random stuff at the bottom. I think it helps to put this all in a class. So I'm going to kind of shift this into a class called game. Create our constructor. 90% of this stuff is just going to live in our game constructor, constructor is going to take that board, call it board string in a second. It's just going to help us be organized because our game class is going to own kicking off the animations and creating the ghosts and all the things that need to happen. So it's gonna be good. It's gonna be grateful. So now instead of this dot game, it's gonna be this dot game. It's gonna be this dot board. Yeah, and this we could put in like another method called like setup board, but like I don't care that much. Instead of game.append, it'll be this dot l dot append. So I will call it this dot element. Let's see, we get the square size. This is going to live on game.squarewidth, game.squarewidth and game.squareheight. Do you ever program in Backbone.js?
I tried like years and years ago, but it's not something I ever like got into.
Yeah, that was, I mean, that was the first kind of framework that I used for building websites outside of jQuery. And it was like, you know, you basically created these classes. They weren't called classes, but it was like that. And everything had a render method. And a lot of those techniques are kind of similar to what we're going to do here. So we're going to create a new game. We're going to pass in the game string like we did before. Somehow I broke it. We're not quite working yet, but I think we'll get there soon.
One question I have, inside of the classic game, the square width and square height, you're referencing that class. So you're adding those properties onto the class?
Yes. Yeah, so what we're doing is we're making these basically like global variables, but they only work on like they're just like properties of game. They would be called like a static what is it? Not a method, but a static variable on the game class. And that's just because I didn't want to do a global variable. Let's do game.squarewidth and game.squareheight. I think that might have been what was broken. Okay, a little bit worried. I broke the game. We're gonna call this .critter, .critter.l. So this happens sometimes. Things break. Board is not defined. Right.
That's all part of the fun of refactoring, right?
Yeah. It's gonna work in this. I mean, you'll know that it works because you can see the thing. Yay! Yeah. I fixed it. Woo. Okay, so now we have a game class that is actually taking care of things. And the other thing that I want to make now that I have the game class, you saw how I created these critters, this critter, but I want to also make the ghost. So we can have the critter take X, Y, and a type instead. And then for the X, Y, and the type, we are going to say, like for our little critter, we'll say we want X of, what was it, 12, Y of 8. I might have got that backwards. No, that's right. And then a type of critter. But now we can reuse this to also create our ghosts. So our ghosts, we're going to create these. We're going to create like a ghost here. Const ghost equals. Hey, come on, you need to work now. So I want my ghost to work. I need to append my ghost. Okay, console says creature is not defined, right? I copied this from another version, and the other version I called it creature instead of critter. Huh? Got that. Don't have the ghost.
Did you ever define the ghost? You did, right? Wait, did you ever define the ghost?
So we've got type as ghost. Type? Let me make sure. Yeah, I don't actually use the type. So here I use the type, and now, no.
It's just not using the coordinates. It looks. Oh yeah.
Oh yeah. I hard coded the coordinates. Great. Yeah, hard coded the coordinates. So I love this this syntax here. It's very common in React as well to use destructured parameters. It's just beautiful. So we've got our ghosts now, and we need like a bunch of ghosts. You know, you don't want just one ghost. You need to have a whole troop of ghosts that are coming in. And I know the ghosts in the game are color coded and they move, and ours are not going to do that, but it's going to be cool. So we're going to change this to an array of ghosts, and we'll say new critter, 12, 13, 14. So now we've got our array of ghosts there, and then we'll go, what is it? This dot ghost dot for each ghost, and then we can say this dot l dot append ghost dot l. Okay, so now we've got our ghosts. Nice. Yay! And they're cute. And I mean, these are the happiest ghosts. Like if I was being chased by a
Right.
ghost, I would love to, I would hug the ghost. It would just be a good ghost. Um, okay, so I'm pretty satisfied with where we've got right now. Like we're what, halfway in?
Yeah, almost.
Okay,
Yeah,
okay.
you got 32 left.
32. Oh yeah. We're good. We're good. So we've made the game board at least. It looks nice. It looks exactly how I want it to look. Um, the next thing that we need to do is add some like ability to move stuff. Like right now, you can't move anything. And so I really need that to happen next. So in order to do that, let's go ahead and add this concept of move. But before we do that, I gotta let in my dog. My dog is very eager to come in. So just give me a second.
Are we gonna get a dog on stream?
Come on.
Oh, dog. This is the first dog on stream.
Hey.
Aw.
He's my golden doodle. He's a big buddy.
Not so much of a lap dog.
Oh, no, but he likes to sit on my feet and hang out. And I like that. So yeah, so I've got my dog now. I'm all set to go. He's gonna take us through the second half. His name's Milu. He's a half golden doodle, half Great Pyrenees. So he's extra big and fluffy and very calm, unlike most golden doodles. So we're very happy that he's in our family. So I mentioned before that in order to move a thing, all we have to do is change the X and Y coordinate and then redraw it. So the dog is like, pet me now. So we're gonna create a way to do that very soon. But one concept that we don't currently have is direction. So with when you're moving, you're going to be moving in one direction until you stop moving in that direction. So we're going to set a variable called direction, and by default it's just going to be empty string. That's kind of I would say the first step. And then the next thing that we need to do is add an event listener for key down. We're going to listen for arrow, right, left, whatever. And then we're going to set the direction to the direction that I want to go. So let's do that next. In my game class here, I'm going to add a new method.
I don't know if you hear that beeping, but now it's officially 30 left.
What? Set up keyboard events. And then we're going to say document.body.add event listener. And I've had some trouble with CodePen when I was practicing this, where it would swallow the keyboard events in the iframe to the parent. And so if it stops working, I'll pretend that it's working. So we're going to caption event. And then I don't know if your audience is familiar with this. There's about like 50 different ways to figure out what key is pressed. You've got e.code, e.which, e.keycode. And let's clear all of this. And I just want to see if I can get them to trigger, because this is kind of weird. Oh, come on. Don't fail me now. Okay. So, we haven't actually called setup keyboard events. So at the bottom of our thing, we'll say setup keyboard events. And now it should be listening. So if I press up, you see we got arrow up, 38, 38. Okay. So our, that's e.code, e.which. Check out spacebar, which we need for pause. You've got e.code is space, e.key is a string with one empty character in it, and then you got 32, 32, left, right. So, I mean, there's a lot of different ones. I think e.key is kind of the recommended one these days, but they all sort of work. So I'm going to say if.key.starts with arrow, because it's going to say like arrow up, arrow down, arrow left, arrow right. Then we're going to say this.critter direction equals e.key. We're just going to straight up use arrow left, arrow right, arrow up, arrow down as the direction, and then we'll use that later in the in our move method to move it. And then we'll say I'm also going to add, we'll leave out pause for now. We don't need to pause yet. Eventually we might add pausing, but for now the key thing that we want to do is set the direction that we're going. So I'm going to press up. Now the direction is up. Now we actually have to move it. In order to create animation, right, you need to create some kind of loop where it does a thing and then does it over again. And while there is something called request animation frame, we want to control how fast it moves, because you don't want this thing zooming around too quickly. So we're going to create, well, what we're going to do here is we're going to create this dot move to say let's start moving, and then we're going to create our move method, and then we're going to create at the bottom of move, we're going to call this again after 300 milliseconds. And you can imagine, you know, we could set this in a variable and decide like what the right cadence is, but this is like pretty good. And then while we're moving, you're going to think of what are the things that we need to move. Well, we're going to need to move the critter and then the ghost. I don't think we're going to have time to get to the ghost today, but I'll have a different method called move critter. And then in our move critter, we will say, just for now, this dot critter dot x plus equals 1. So let's see if this starts to move. It doesn't move because we also, after we move, we need to draw this dot critter dot draw. So we move it and then we can draw after it moves. We need to redraw it. Yeah? No? It's not going to work? Okay, that's fine. It's trying me. I think I can figure out what happened here. Let's see. So if we set the X, we redraw the critter, it should move. And if it's not moving, it's because of what? Let's see. Let's see if it is actually changing anything. So the XY don't appear to be changing, and we're getting type of draw of undefined. Right. So does our critter class actually have a draw method? It does. So critter has draw, which sets the top and left like we want. It should move it. But this dot critter, is it set? Yeah, this dot critter equals new critter. Okay, good. This dot critter dot x. Let me just log in here this dot critter and make sure that I got my variable name right. Undefined. Wait, there it is. There is a thing. Okay, can't find draw of undefined. So what I'm trying to figure out is like the first time I do this.
I think you're missing a T there.
Yep. So good at spelling. Thank you. Yeah, so now it's running away. It's running away, which is good. We kind of wanted it to run away. So we can use the direction. So we can switch. We'll say this dot critter dot direction. And obviously, it probably would usually makes more sense to actually do this inside of the critter class, but we have to know about the walls. And only the game knows about the walls. So I haven't passed in the game information into the critter class. So I'm just handling this in the game class up here. So we're going to switch on direction, and we'll say things like case arrow left, then this dot critter dot x minus equals 1. And then break.
I love that it's currently looping. Just
yeah. Anytime I change the code, it'll just re-render. So case arrow right. This dot critter dot x plus equals 1. Break. Case arrow down. This dot critter dot y plus equals 1. Break. And case arrow up, this dot critter dot y minus equals 1. Right. So fairly repetitive code here, but this should get us to move in the direction that we tell it to at least. Oh, it looks like my math is a little bit off. So it's like it's not quite over the dots at the beginning, but it is toward the end for whatever reason. So there's a little sort of off by 1 error on my map, but that's okay. So it'll move in the correct direction now, but now the problem is it's just running, it'll just go out to like negative however many, which is not ideal. So we can put in a little bit of like super basic collision detection here. If this dot critter dot x is greater than 1. So basically don't let it move to like, so this will get us, let's see, this should make it so that I can't leave off the left-hand side. Okay, so my the character's not quite exactly aligned perfectly, but you get the idea of it. For this one, we'll say if this dot critter dot x is less than this dot board 0 dot length, which board 0 is going to be the board is the the array, two-dimensional array, and board 0 is going to be basically one row. So the length of a single row all the way across. If it's, as long as it's less than there, then we can allow it to get bigger. And then similarly, for Y, for arrow up, you know, we're not going to let it crash through the bottom. We're not going to let it crash through the top. So if this.critter.y is less than this.board.length, so we're just keeping it in the outline. So now I can go over to the edge, out touching anything. It's not going to leave the screen. And yeah, I'm sad that it's off a little bit, but it's not going to go anywhere. The problem is we don't have well, there's a couple of things that we're going to fix from here, but the first thing that I really want to work on is I really don't want it to be able to run into stuff. Like I don't want it to run into these. Let's see, can I hit save or is it going to make me sign in? Okay. I don't need to sign in. It's fine. I'm on like incognito browser, so like I don't know, signing in is hard. I don't remember my password. Yeah, so it's contained, which is good. We've got our basic, we can move it. We've got our basic collision detection to make sure that it can't just go outside the bounds. But now there's a couple more things we want to add. So from here we can do, we can make it smoother. So I don't love how this is just jumping, you know, a lot. And so I think the next thing we're going to do is we're going to make it smooth. And then once we make it smooth, we'll see if we can eat things and prevent it from going into walls. Does that sound like a plan?
Yeah, that sounds great.
15 minutes. We got 15 minutes.
You got this. You got this. Well, it's about 20 minutes now.
Oh yeah. That's fair. We didn't start running the thing. So we know that we're moving every 300 milliseconds. So what we can do is add a CSS transition. I said our CSS was done, but there's a few more little details we're going to add to make it even nicer. So check it out. If I go into CSS here, look at my ghost and my critter, which are here. So we've got position absolute. The next thing we're going to add is a CSS transition property. And I'm going to tell it that I want to animate the top value, and it's going to animate smoothly over 300 milliseconds. So right now we move, and then 300 milliseconds we move again. This will smoothly animate between values. So we're going to tell it, especially it's going to do a linear animation. So don't like go fast and then slow, just completely smoothness. And then you can add a second transition property here. So we'll say left 300 milliseconds linear. I can't tell you how long I looked to figure out if you could even do more than one transition at once, because I thought maybe you could only put one property. And then I tried things like top, comma, left, and that didn't work. You've got to separate them and put them out like this. Or there's also another thing called, like,
I definitely used all for a while until I realized that.
I just used all because it's so much easier. I think in Candy Critter, I still use all because I couldn't figure out how to do this for a minute. So from here, now it's smooth.
Lovely.
It's so
That's
smooth,
awesome.
Which we love. We love the smoothness. So that's good. I'm feeling good about this. That was good. So smoothness is nice. Good. Just a little CSS transition magic there. Again, coming back to my CSS3 old golden days when I worked at a design agency and I had to make everything look really sharp. Let's add a little bit of protection from running into walls next. So we're feeling good, like, hey, I can move around, but I don't want to be able to smash into the wall. Like, it needs to stop at the wall and not let me keep going. Not just the outer bounds, but actually the wall itself. And the way that we're going to do that is we need to add a little bit more checks. And I'm just kind of thinking on the best way to do this, because there really are a few different ways that we can, accomplish this. I think what we're going to do for this particular one is I'm looking at my sample code to remember how I decided to pull it off, because like I said, there are a few different ways. I thought what I had was in my move statement, in my move critter, like I've got all these checks to see if I'm on like the outside, but I can also do more checks to say if I'm hitting something. So what we'll check here is basically we move it and then we draw. But before we draw, we're going to check if we hit a wall. And if we hit a wall, we're not going to draw and we're going to restore the value. So what I'll say here is if this.board this.critter.y -1. Basically, I'm translating the XY position, which is 1 based for our critters, to 0 based for the array. And then this dot, this dot critter.x. So yeah, 2-dimensional array. If that equals 1, so if I hit a wall, if the current XY position I'm at is a wall in the array using this 1 string, then instead of drawing, I will return. Now this isn't quite good enough, and I'll show you why in a second, but it is something. Yeah, so it paused at the wall and then it jumped over the wall, which is not exactly what we want. So the problem here is that even though we've paused it at the wall, the XY values are still changing. So as soon as in the loop it gets to the next place, it just hops over to that new place. So in order to keep it where it is, instead of to move it, we're going to save the original XY value. So we'll say const x comma y equals this dot critter. So before we move it, we store the original XY. And then if it's moving into a wall, we'll say this dot critter dot x equals x. And this dot critter dot y equals y. Not found. Cool.
I really hope that CodePen doesn't just too many saves.
Yeah, it's mad at me that I didn't click the save button. 100 plus unsaved changes, discard. All right. Well, the good thing is I've got backups of all this. I've copied all the code over. I'm going to open a new CodePen. We're going to start over. But I'll just paste in the JavaScript, see if it works. JavaScript, good. CSS, come over here. Good. HTML.
The huge HTML document.
Massive HTML. Huh?
Yay.
So we're good. We didn't lose too much. And now it stops at a wall. It can't go through the walls. So this is like not advanced. I'll tell it for people watching this. The best document I've read about collision detection, and because I'm just using like XY coordinates, but the best thing I've read about collision detection is in this the Mozilla developer docs, the MDN. It's got this whole thing about like different ways to do collision detection based on if you're a partially overlapping rectangle, if you're a circle in a circle, it has like tells you the most efficient way to do it based on what you're trying to find. Like, are you just trying to detect if the middle of the thing collided or the edges? So this is I don't know if you have a resources. I would share this out because it's a really good.
I just sent that in the chat and I'll include it in the description.
It's super fun. And basic collision detection, like I learned this when I was like learning game programming, when I was like, I don't know, in middle school, reading books about like Java game programming or something. But like, it's just like a cool idea. And it comes up obviously in a lot of different types of games. I have a Tetris game that I was working on. You got to do a lot of collision detection there. So,
and just a heads up, it's officially under 15 minutes now.
Okay, so the last thing that we're gonna do, well, you know what my favorite thing is, and I think the better for learning is the next thing I want is for the character to be able to die, and then if we get death in, then we'll get eating. So in order to die,
death before eating.
Yeah. Wait a second. I don't know if I will go in that way. So this is an obscure thing that I want to do here, but I'm going to show you. We're going to add a class called dead to our critter. And what I want to do is play around with the CSS thing called CSS filter, or what used to be called SVG filters. Have you heard of this before, Colby?
Yes, I have heard of. I haven't used them too much, but I've heard of them. Yeah,
they're so cool. Yeah, and in my opinion, underused. You can do all sorts of really interesting things. So I want my character when they're dead to look super dead. And so I know that we've got a new emoji we're going to swap out, which is fine. I'll put that in there, but we're going to use some CSS filter. And I know this is like tiny. Let's see if I can do a little bit better job to make it even more dead looking. So I've got brightness here of low. So I kind of turn on the brightness. We're going to do like a little sepia tone here of 0.4. We're going to do this hue rotate thing, which is going to kind of just shift the color. So you can rotate the hue of like an image. Like an emoji is basically an image, but with CSS, hey, what happened? I'm missing degree. With CSS filters, and then I'm going to saturate this a lot so it looks like all red and dead emoji.
This is blowing my mind. I'd never thought about using those kind of things for like on an emoji.
Old school, like in the old school days, like when you had like a hover over, it'd be like gray, and then you hover over it and there's a color. So you can do that, but instead of using, you know, swapping out the images, you can use CSS filters to really nicely, like, you know, just make something black and white really quickly and make really nice effects. I think it's a fairly underused feature. So let's go now. I just kind of showing it off in the terminal there, or in the console, but let's go and actually make our, we're gonna have critter.dead. And remember, we had a special variable for that, the dead face there. And then we're gonna do critter.dead, or sorry, this is gonna be :after. And then for the actual apply the CSS filters. So we're gonna make it kind of red looking. So I'm just gonna copy this over from my working copy here. So we've got filter, and then we're gonna lower the brightness. We're gonna up the sepia. We're gonna rotate the hue, and we'll saturate it. This is actually probably too much. But you can see our poor little emoji there. It's like the
looks pretty dead.
The X'd out eyes, but I made it all red. I think in an earlier version, I also used text shadow, but I feel that like I was overdoing it with my CSS3 with the text shadow, because you can use a text shadow and it'll go around the emoji. It'll go around the edge of the emoji. It's like text. It's kind of fun. Okay, so now we have the CSS for dead, but we actually need to allow it to move. So let's go back into our JavaScript. So what we're gonna have to do is do a collision detection to see, have I gone where the ghosts are? So what we're gonna say is after it moves, and we've got our move here, our move thing that gets called every 300 milliseconds. So we're gonna move the critter, and then once it's moved, we'll say check collisions. So we're gonna have that here. We're gonna add a new method, check collisions. And what we're gonna do is we're gonna loop through all the ghosts and say this.ghosts. Wait, can I use a sum here? Yeah, I think you can use sum. Ghost. So basically, if any of the ghosts, and we'll say ghost.x, because we're just using this simple coordinate system. We just know if a thing is on a square or not on a square. There's not like a fancy partial square. You're just in a square or you're not in a square. So if we're gonna use sum here, return. So
10 minutes left.
Cool. We're good. So return ghost.x triple equals this dot critter.x, and ghost.y triple equals this dot critter.y. So if there's a crash, so if the ghost is on the same square as the critter, and we're going to check this as soon as the ghost moves, we'll check if they crash, then we will say this dot critter dot die, and then back on our critter class, all die means in this case is we're going to add a class on them. Die this dot l dot class list dot add dead. Okay, so given that, I think this might work. Nope, I'm already dead. What have I done? Did I say X or Y? Because it's already on the same X. No. Oh yeah. No, I always crash. So I have to say if crash. Okay, so we only want to call it a collision if you actually collide. So let's go up here.
Nice.
Okay. So it is dead. Unfortunately, I want my critter to take priority over where it is. I wonder if I add the critter in the DOM after the ghost, if it'll show up. Obviously, I can use, let me just check if this works.
Would Z-index fix that?
I mean, Z-index could fix that, but that is like a last resort. When you mess with Z-index, all things get a little bit wild. Oh no, I broke the game. What have I done? It worked until I just moved that around. There we go now. Okay, good.
There we go.
Now it's still dead. Let's see if all I tried to do was append the critter after I appended the ghost. I was just curious. Yeah, now it's ahead. Nice. So I guess if it's somewhere else in the DOM, this appending gets added to the bottom. So last thing may take precedence. I don't know. I'm not drawing any conclusions there, but you can still see it. Now the last thing I want to do in the last 5 minutes or so is figure out how to eat our food. So it's important that we get a little nourishment when we're getting chased by ghosts. It's a scary time. And so in order to eat, let's see, how are we gonna do this? I'm trying to remember the best. The best.
You ever see Zombieland?
No, what's Zombieland?
It's like a funny zombie comedy movie, but he has a huge list of rules for running away from zombies, and I have to feel like nourishment is in one of those.
Yeah, I don't know. You gotta take it easy. You can't be too stressed out about getting eaten by zombies. So in order to eat, we're gonna have an eat method here, and I'm trying to think, like, do we add this after we do the collision check? I guess it's kind of like a collision-ish thing. And in fact, let me just throw this in for the check collisions code. So we'll first check if you crash into a ghost. That seems a little bit serious. But then if you don't crash into a ghost, we'll just check if you crash into some food, which is like not so bad. So crash into food. So we'll say something. In order to figure this out, though, what we're gonna do is we're gonna figure out if we crash into the food, and if we do, we have to remove the dot or the candy class, right? We have to remove that. So this is like a surprisingly annoying amount of work. Actually, you know what? I'm gonna put this in its own method. So eat is gonna be a thing. Where I call check collisions. So we check collisions. See if you're dead. If you're not dead, you're gonna have some food before you move again. So in order to get the index of the dot that you're on, we're gonna do like some math. We're gonna say this dot critter dot y minus 1. Remember, it's 0 index versus 1 index times this dot board 0 dot length times the row length plus this dot critter dot x minus 1. I know it's a little bit annoying, but what you're translating here is a 2-dimensional space to, like, I'm the 77th item in this list of divs. So again, if we go back into our elements here, there's a ton of these squares. And so in order to get the sort of 1-dimensional index, we've got to do a little bit of math. And then we can say const L equals this dot L. And again, this is our game element dot children index. There's probably another way to do this. L dot class list dot remove, and we're going to remove both candy and dot equally. Obviously, like in a proper game, we would give points for what thing you ate and all that good stuff, but we're not gonna mess with that right now. So as I go through the world, is that it? Are we done?
The 5 minutes left.
Oh, 5 minutes. It's going to eat the dot. Now, it's a little bit annoying. One thing you can kind of tell here is it eats the dot before you get there. And it also will kill you before you get there. Because of our CSS transition, we basically say, move to the thing, check it, and then it's going to smoothly animate to the thing after we already do our work. So like you can do a little bit more careful about how you, like where you set your timeouts. And like, if I, like, for example, I wonder if I did a set timeout on like eating and checking collisions at like 299, if I could get those to run just before we move again, if it would look cooler. So I'm going to try that out. Yeah, wait. So now it eats the thing right before the transition ends. Uh-oh, I'm stuck. What have I done? I shouldn't mess with it too much. Anyway, that's really all I wanted to show off, to be honest. So moving around.
Can you eat the cherries?
Stuff, collision detection. Oh, the ghosts?
The cherries.
The cherries. Yeah. Let's eat the cherries. Oh, come on. What have I done? I've got it off by 1 error. All right, I'm not celebrating yet. I've gotten off by 1 error. I can't eat the cherries. That's horrible. All right, let's see what's happening here. What have I done? It used to work. Let's start over. Let's see if it works. Okay, I'm gonna go over here. I should hit the wall. Normal, up, back over, down. It can't go. I'm stuck. I'm stuck in a rut here.
Is it every time you hit down that does it? Is it only when you hit down does it get stuck?
I think there's, yeah, can't read property 19 of undefined. So I think my let's see, it's the move critter method. It's like, I think there's an off by 1 error. here, or I go sort of too far. So I've got to check my logic a little bit, because I didn't have this problem in my.
Oh, I think I see it. I think in arrow down, see how it's this board, you don't have the 0 index. Is it that?
No, because the Y,
Okay.
the 0, the initial one is like the number of the rows versus the columns. So that kind of makes sense.
Right.
Do I need a greater than equals? That's fine. We'll figure it out. Is my stopper backwards? Or should it be less than? No, that looks right. Less than this dot board dot length. That looks right to me. We'll debug this. It's gonna be cool. Oh, yeah, don't not save. I just have to like type random things to get it to refresh. Okay, so I can go over. We're good. I can go up. Let's see if I can go up. Is it always just when I get to the edge? No, I can eat that.
But it ate the cherry. Yeah.
Yeah, that one's fine. So there's just a problem with the bottom corner, weirdly.
Oh yeah, that's interesting. Because can you still move around now or no?
No, I can't get over there. So
it looks like the bottom row totally then, right?
Yeah, can't read property 2 of undefined. And if I go back, yeah, I think I've got like a little off by 1 error or something. So
does it need to be length -1 or length +1? Do you need to translate it from the 0 to the 1?
Something like that. What is wait. So when it says it can't read the property of undefined, what is the thing that's undefined? So I don't get a line number on here. Wait. Okay, so it's this check. Oh, excuse me. My board check. My wall check. So this .critter.y -1, this .critter.x -1.
So it must not be finding that y. That's my guess at least.
Yeah. Let's we can debug this for the next 30 seconds before we run out of time. So I will log the x, the y, which is the previous one, this .critter.x, this .critter.y, and then that's a lot of things to log, but hopefully we'll figure out. And then I guess you've got like a console log. And let's see. So as I'm moving along, 1 minute warning.
Nope, that's 0.
Oh, we're out of time. We didn't fix it. No.
I think you did a pretty heck of a good job. Good job.
I had fun. That's all that matters. Thanks so much for having me on your show. It was a lot of fun.
I'm so glad you were able to come on. This has been awesome.
It was pretty good. Here's our undefined. I don't know why it's undefined. Again, it's off by 1 error. I got to do like -2 or something, but it's all good.
Totally understandable.
Thanks a lot for having me.
Yeah, man. So before you head out, do you want to take a second and just like poke through what you just created?
Yeah.
If you don't mind. If you don't mind sharing quick.
Let me share my screen again here. And which one am I at? I think this is it. Is this the right screen here?
Yeah.
So what we created together in the last hour was this basic Pac-Man game. And, as far as what you can do, you can move around, you can eat stuff. There's a few little formatting problems, but overall it works. And it detects the walls, so you can't crash into the walls. And if you do happen to run into a ghost, even though they don't move, it'll switch your face and apply some fun color to make it look a little bit sad when you get eaten by a ghost. So as far as how this works, essentially what we've got here is, hey, watch out. Search, I don't need you here, taking up all the room. We've got 2 classes. We have a game class, and the game class takes this string here, which this string, I didn't really demonstrate this earlier, but it's really fun because you can just we can just change, like, let's say we want cherries everywhere. We want just like unlimited points. If I modify this, it's just gonna change what you see on the screen all over the place. So we can do some really cool things just with a simple string to create our game board. So it takes in that string, converts that to a 2-dimensional array, And then for each of those items adds a single div for every single thing that you see on the screen. And we're using CSS grid to lay those out really nicely so it's all evenly distributed across the screen. We later use window.getComputedStyle to measure one of those individual squares, and we use that to sort of determine where our little Pac-Man emoji is supposed to be on the screen. That is using a class which we call critter, and both the ghost and the Pac-Man characters share the same class of critter, which just has like some super simple, it creates a div. Those divs live as children of the game, but they're not aligned with CSS grid because they're positioned absolute. And then we set the XY, we set the top and left and absolutely position them based on their XY coordinate, which is meant to map to this game grid. And as you can tell, as I move this around a little bit, it's not like perfect. And like the further I get away from center, the more sort of off it becomes. Like when it gets to the edge, it's like it shouldn't be over there. So you can kind of tweak the logic around exactly, how wide you need to move. There's a little padding and stuff that you need to sort out there. But yeah, we just have the simple class that controls our critter. The most important thing really is the XY element. And then when we draw, all we're doing is just updating the top and left. So in addition to that, we've got keyboard events that keep track of which arrow you press. That sets the direction. And then in our main move loop, we tell it to move over one in whatever direction we chose. So pretty fun, nothing like super complicated in my opinion, but I love making games like this to just learn basic web technology, refresh my skills, make sure I get to try CSS grid and CSS variables. You see, we set all these variables at the top here, which is it's just a really fun way to organize your CSS.
And I feel like trying to think through the grid is something that you don't typically have to think about in typical web development, like the turning it to a two-dimensional array and like the positioning and all that stuff.
Yeah, all the positioning stuff is you're definitely not usually doing that in web development. But thinking about a grid and okay, well, this is what I'm doing with CSS grid. Well, how could that apply? Because CSS grid definitely applies to a lot of different styles of websites we build. I think that's fascinating. I think understanding understanding some of these basic techniques, even collision detection, you're not usually using that. But if you're doing something automatically, maybe you can use the collision detection if you're hovering over something to start preloading code, or if you're as you're scrolling to check certain things with scroll position. So some of these techniques, even though it's not obvious fit with making websites, I think they're helpful here. Another thing that I love when I'm doing side projects or just fun projects like this is just going as raw, no React, nothing like that. I want to understand the core technology. I have this Tetris game that I did similar, and it's CSS, or sorry, it's ES6 modules for everything, but just raw in the browser. I just think it's fun to see what the web is capable of without all the frameworks, because we have so many frameworks and tools that we put on top of what we do. Sometimes it obscures the actual potential that's there natively.
Totally. Well, that's awesome, man. I thank you so much for going through the challenge and everything. If you want to keep your screen up for a second, just because it messes with the overlay. But yeah, sorry. No worries. But thanks everyone for joining. Jamund, I'd also like to thank you for accepting the challenge of Colbyashi Maru. Everybody, please be sure to go check out his Twitter and of course all of his courses on egghead.io. You can see all of his awesome learning, like Redux with the Redux hooks, like we see here. I love the egghead illustration style there. It's just so cool. But next week we're gonna have Shruti Kapoor, where she'll face off against querying app data with GraphQL. So Jamie, before we head off, any last words?
Thanks everyone. You're all cool. Keep making amazing websites and using JavaScript forever.
I love it. Awesome. Well, this is Colby signing off.